Hi everyone, let's wrap up this section with a few miscellaneous topics. We've already discussed the definition of a logarithm, how the logarithmic function is a inverse of an exponential function. And now let's take a little closer look at finding the domain and possibly the range of a logarithmic function, intercepts, and finding the inverse actually. So in an earlier video we did domain and range of an exponential function. So now let's talk about the logarithmic function. Okay, first of all, we have a function f of x equals 8 plus the natural log of negative 3x plus 4. But what we have in our toolbox is the fact that no matter what the base of the logarithm is, whatever's inside the logarithm has to be positive. And that's key. Okay, so here, the argument is negative 3x plus 4, and it needs to be positive. So since this inequality is linear, we can simply isolate x, and dividing by a negative changes the direction of the inequality. So we have x is less than 4/3. So our domain in interval notation would be minus infinity to 4/3. And it's an open interval, so there's a parenthesis there. Okay, because again, what's inside the logarithm cannot actually be 0. Now to find the x-intercept, you're going to let f of x equal 0. And f of x is 0 if we have the equation 0 equals natural log, or excuse me, 0 equals 8 plus the natural log of negative 3x plus 4. And now step back from this. This is a logarithmic equation. And it's a single log. And everything else is numbers. So ideally, we want to write this as logarithm equals and use the definition of the log to rewrite it in exponential form. Okay. All right, so let's go about that process. So we'd have negative 8 is natural log, which, by the way, is the same as saying log base e of negative 3x plus 4. So in exponential form, we have e to the negative 8 equals negative 3x plus 4. This equation is linear in x. So we can isolate x. So we have the number e to the minus 8 minus 4 equals negative 3x, or minus e to the minus 8 plus 4 equals 3x, or minus e to the minus 8 plus 4 all divided by 3 equals x. Okay, and presumably this is the x-intercept, but you still need to check it all the way back in the original function. And what you're checking is the argument of the function, meaning is the part inside the logarithm actually positive when you insert this number. And I'll let you go back to your calculator. The answer, by the way, is not always yes. In this case it is yes, and you can check, but make sure you check. Okay, now so we have the x-intercept, and that satisfies the question at hand. I'd like to extend this question and ask, what is the inverse function, just to make sure we understand this process. So let's recall. of the function itself is f of x equals 8 plus the natural log of negative 3x plus 4. And let's recall how we find inverses. We're going to let y equal f of x. So y equals 8 plus the natural log of negative 3x plus 4. We're going to swap x and y. And so we'd have x equals 8 plus the natural log of negative 3y plus 4. And then lastly, we'll solve again for y, but this time, because we've swapped, the y that we find is the inverse function. Okay, so solving is much like what we did just a few minutes ago. This time we're solving for y. It's inside the log. So we have to isolate the logarithm. We note, and I'm doing this for a visual aid, that natural log is log base e. And now we're going to write this guy in exponential form. So basically you go back and forth. Log form converts to exponential form, and exponential form converts to log form. So converting this to exponential form, we'd have base e to the power x minus 8 equals the quantity negative 3y plus 4 We'll finish it off by isolating y, doing the algebraic steps. And we end with negative e to the power x minus 8 plus 4 all divided by 3. And this guy is your inverse function. Now remember we said that the domain of your function, which we said was minus infinity to 4/3, will actually be the range of the inverse if we were to graph this guy. Okay, and the domain of your inverse, which in this case is all reals because it's a simple exponential function, is actually the range of the original function. Okay, now there will always be that relationship.